Hello class, in this video we will be focusing on the concept of probability and going through some of the topics covered in section 8.1 of the text on probability. Before we get into a couple of example problems, I want to make sure that we iron out a couple of vocab words. So depending on if you've studied probability before, these may or may not be new to you. The first that we're going to look at is outcomes. Outcomes of an experiment are all the different possible results of an experiment. The sample space is the set of all possible outcomes. Normally, when we're conducting some kind of experiment or simulation, we have a specific outcome that we're looking for. And what we do in probability many times is we try to figure out what is the probability that we will get a certain outcome. The way that we do that is if we have a specific event that we're looking for, we'll do an example of this in a second. The probability of an event E occurring is calculated by taking the number of favorable outcomes of our event that are possible and dividing that by the total number of outcomes. So let's give it a couple of examples of that. Let's just start really simple and say that in our experiment, what that consists of is rolling a six-sided die. And we want to know the probability of rolling a 2 on a single roll. Now, probably you could calculate that in your head without even showing any work, but just so that we bring in some of these vocab topics, let's do this a little bit more academically. The different possible results of an experiment are the outcomes. The sample space is a set of all possible outcomes. So in this case, our sample space is the set of numbers 1 through 6. So there are a total of 6 possible outcomes from this experiment. If the event that we are interested in is only the event that we roll a 2, there is only one way with a single die that we can roll a 2. So the probability of rolling a 2 would be the number of favorable outcomes. So in this case, the number of ways to roll a 2 divided by the number of total outcomes, which we've already established in this case is 6. Now, we wouldn't leave our answer like this because we're not yet totally in numerical form, but the number of ways to roll a 2 on a standard six-sided die is just 1, so the probability is 1/6. Before we do another example, I want to bring up another important point that will be crucial for you checking your work for accuracy. In any given experiment, the probability of an event is always going to be between 0 and 1. If you ever calculate a probability and either get a negative number or a number greater than 1, that should immediately set off some alarm bells that you've done something wrong in your calculation. And if you understand sample space and probability a little bit, you should be able to understand why. If the probability of an event was 0, that would basically mean that it is completely impossible for that event to happen. Okay? So, for example, rolling a die, a six-sided die, and getting the number 7. Obviously, that's going to have a probability of 0 because it's not possible to get a 7. If the probability of an event is 1, we would say, and in the textbook you would find this as well, that that is a certain event, meaning it is 100% guaranteed to happen. So if you had a special coin that was heads on both sides of the coin, and you wanted to know if you flipped that one time, what was the probability you would get a head, the answer to that would be the probability would be 1. Any number between 0 and 1, any decimal number between there, represents a percentage, and that is the percentage chance that your event is going to happen. So if you end up with a probability problem and you get the answer of 0.40, the way that you need to interpret that is that there is a 40% chance that whatever event is being described is going to happen. Now, before we close out this video, let's take a look at one more probability example that's a little bit more difficult and also talk about one other concept for calculating probabilities. Let's say that in this example, we are going to flip 3 coins simultaneously. And the event that we are interested in, let's call it event A, is that we get exactly 2 heads. The question is, what is the probability when we flip 3 coins that we will get exactly 2 heads? In order to answer that question, we basically need to know 2 things. The first thing we need to know is when we flip 3 coins, what is the total sample space? What is the set of all possible outcomes that could occur? One way that's discussed in the text that is a good way for figuring this out is using a tree diagram. It's not the only way, but it is a good method. So let me explain a tree diagram to you really quick. On the first flip of your coin, you can either end up with a head or a tail. On each successive flip, you can again end up with a head or a tail. And so you see that if we continue with this process, we are building a tree that is going to give us the set of all possible outcomes. The way you read this tree diagram is each unique branch, starting at the top of the tree and ending at the bottom of the tree, represents a unique outcome. So, for example, if I start at this head and I continue down here, I arrive at the outcome H, 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 meaning I flip all 3 heads. I could also start here, go head, head, and then tails. H, H, T. And if I continue with that, I'll go ahead and list all the possible outcomes. You're going to end up with all of the possible outcomes that can occur. In this case, reading our T diagram, we have identified that there are 8 possible outcomes that can occur when you flip 3 coins. Now, it's important to note that you may be tempted to count heads, heads, tails, and something like heads, tails, heads as the same outcome, because in both cases there's 2 heads and there's 1 tail. You need to include both of those in your calculation of the sample space, because although in terms of the number of heads and tails they're the same, they are going to affect the overall probability. It's also important to note that when you use a tree diagram, an easy way to see how many elements there are in a tree diagram is just to look at the bottom row. The bottom row, which in one sense represents the number of branches, will tell you how many outcomes there are in the sample space, in this case 8. So now we've listed the sample space, and now we need to know in how many ways can we get favorable outcomes for our event A, which is exactly 2 heads. So in order to do that, we simply need to examine our sample space and identify which of these outcomes has exactly 2 heads. Here's 2, and it looks like there's 1 more. So in our sample space, there are 3 favorable outcomes, ways that we can get exactly 2 heads, and 8 total outcomes. So the probability that we will get event A, that event A will happen, P of A, is 3/8. If we're asked for a percentage, we could put that as a decimal and round it to the nearest whole percentage. Hopefully this gives you a good introduction to the concept of probability and a couple of example problems. I will be doing a couple more short videos from section 8.1 on some of the other topics in the section.